65 recording, section 65 recording. So I'm going to make sure I got the recording on this time and make sure I share to the screen. There we go. So we should be all set up. Hopefully I've got everything this time. Didn't miss anything. All right, let me just minimize that for a second to go over this schedule. What I plan on doing today is finishing chapter 13. That's right here. And then make sure you take the chapter 13 quiz by this Friday. Excuse me, Sunday, Sunday night. I haven't looked, but I believe, hopefully groups 3 and 4 for both sections have turned in or put their videos up on the display on the discussion board. Excuse me, man, I'm messing up all day. This is going to be a long session. So anyways, hopefully that's up there. Don't forget to do that if you're not. And then next week, last chapter, always one of my favorites, finishing the course out. And next week it's artificial intelligence. I'm going to go over that in a couple sessions. So make sure you do that. You read that chapter as well. And sections, groups 5 and 6 will be doing the technology evaluation. Make sure they have it in on Wednesday by midnight next week as well. And once again, everybody, go through and look at them and, make a comment about each one. I'm going to be looking to see if students are actually watching them, because that's the goal, is that not only the groups go through and learn something, about it while they're doing it, but other students watch it and say, you just learn a little more exposure. Like I said, I think exposure to what technologies are out there is very helpful. Even if you're not an IT type, sometimes it helps you in the world. There's been several times when one of my contemporaries, somebody on my peer group, will show me, say, hey, we're using this technology to do that. And, I may have heard of the technology. And I'm like, oh gosh, I hadn't thought of that. That might solve this problem I'm having in, my organization. So it's always good. The more exposure you get to technology, I think the better it is. So I'm a big fan of that. So I also, now with, I talk a lot about, unfortunately, sorry, about my home automation. I get notifications on certain home automation things in Reddit. So there's been several times I'm like, oh, wow, that's kind of a cool thing. That might be kind of fun to automate here at, my house. And so next thing you know, I'm buying for home automation stuff and automating, doing, something which my wife calls unnecessary automation, but nonetheless, it's kind of fun. And it's what I do as a hobby, I guess. All right, so that's that. Making sure I think I've covered everything. We should be good to go. And so I'm going to bring back these slides. This is where I left off. I went through this chart fairly quick, not fairly quickly. I think I probably went through it in a little bit of detail, just talking about this is kind of the traditional the SDLC, as it's called, systems development, or sometimes it's called software development lifecycle. As it turns out, I don't know if I talked about this last time, but this is very much the approach for both software and hardware. The book talks about it, and I kind of talk about it from the perspective of software development. That's my background. That's where I came from. But it's very similar processes. And as we go through this, I may point out some of the hardware kind of stuff that follows this pattern as well, the same approach. This approach, very, very well structured. I don't know if I went over that too much, but very structured. And it's kind of controversial. Some organizations still use it or still use some form of it. The downside to it, or some of the bad things why people don't like it, is it's very structured. Like each one of these blocks, you go, if you're using strictly the SDLC process, you do your systems investigation. You don't move to analysis until you've got sign off on that. Same thing. You do the analysis. You don't move on to design until you got sign off on the analysis. And that's, it's very formal. And you do all of it comprehensively. You don't just do parts of it. And that's what we'll talk about, some of these other techniques in one of the future slides. But that's why it's very well structured. One of the things that's good about it is it's super structured, and it works. If you follow it very well, you're very rigorous, it works. It actually is, you can accomplish what you're trying to achieve. But the downside is most people don't follow it strictly, and it's very costly, can take a lot of time because of the rigor. So that's kind of some of the downside. It's very inflexible. And so in today's world, fast-paced, moving world, it can be a little burdensome, and a lot of people don't follow it because it is so rigorous. All right, so that's the that. I'll see if there's any other notes. I don't think I have any other notes on that. So next chart just kind of shows, it's kind of an overview that here, this line across here is that same showing, you have some business need, you have something you're trying to do, and these are all those same steps. You can do systems integration, and also this is the SDLC across the middle here. And then some of the other techniques that we're going to talk about is things called prototyping, and I'll talk about when we get that. And some of these other tools. This is kind of a graphical depiction of how these things somewhat can work together, and that's what a lot of organizations, because of the rigor and because of the expenses and all those, the negative connotations of this process. This is how some of these other things fit into it to help make that a better process and a probably, I'd say, makes it actually, probably more successful, because people do follow it a little better. Anyway, so this is just a graphical depiction of the SDLC with some of these other techniques integrated into it. All right, so let me jump to the next chart. And this, I don't usually like to say this session is probably not, I think I mentioned last time, one of the things, when I switched to, I used to do presentations during this time. We'd have a couple presentations, and then when I switched to going, to having them just online and presented, the recorded and then put out there, it kind of gave me a little more time. So these lectures, they're kind of fit weird because I can't really get through all of it in one session, but I have to split it up. So they're kind of shorter. So this is going to be, I should be done in an hour, maybe a little less than that. We'll see. So these are some of the types of people that you usually see in the traditional SDLC, as well as these names usually span across some of the other methodologies as well. The first one, systems analyst. We talked about that in the beginning of the book. I don't remember exactly what chapter, maybe 2 or 3. Systems analysts are those people, and I think I probably mentioned at that time, but I think it's well worth reiterating. Systems analysts are usually the people that are the ones that go out and they talk to the users and say, okay, hey, we got some kind of business need. Talking about that last chart, we got a business need. What is it you need? And they're the ones that interview and talk to people. And what I think this program actually, if you're just a technology and IT concentration, that an analyst, it works really well because you're getting trained on business in general. You have finance, marketing, you have, all these different organizational behavior, all these different business related stuff. And so it teaches you the business functions, or how to an understanding of what the business's, functionality and what they do. But you're also getting the technology aspects of it, and you're getting enough of them. And that's what analysts, a good analyst, and that's when I'm hiring an analyst, one of the things I look for is somebody who understands business and understands technology enough that they can go and talk to the person. And they may not be a hardcore network analyst, a database analyst, or one of those hardcore IT kind of folks or programmer, but they are somebody who can go and talk the talk. I understand how businesses work. I understand all the business aspects of it, and I understand technology, so they can bridge that gap and ask good, smart questions, and able to do, and to articulate to the programmers, the next guys on there. The programmers are the people, once the analysts get all the business needs, requirements, whatever you want to call them, they can take that and document it and then give it to these things called programmers and say, okay, this is what we have. We've designed what we need. And I'm going to talk about that in a minute, what all that means. And so they give it to them. They can start writing code and program what it is what is needed. The other side of that equation is the technical specialists. Like I said, they're the people. And I'm not real big on the word technical specialist. I like the users, or the people that are actually doing it. The business users, I guess, the best terminology I like. But the business users are the ones that are doing the job day in and day out. They're the ones that if they're working on the line. They're like at the recorder's office. You have people that work. They're at the windows, and people come up, I want a birth certificate, death certificate, or whatever. They're the ones that are doing it. They're technical specialists or business users that they know what they're doing. And so this group of people are very, very important to have, analysts talking to programmers, talking to the business users, talking to all of them. And it's very, very important to have all those people available and working on the project, because that's your chances of success are much better. And I think I've talked a little bit about my experience. I am very, very big on, especially one of the things that's happened to me several times is the business specialists, technical specialists, as they call them here, business users. I go and I say, okay, we're going to work this project. You've asked me to go and to develop a new application, or do some kind of new technology for it. I need to talk to the business users, and they go, they're too busy. We need them to do their job. They're all too busy. Why don't you talk to XYZ manager, because they can answer all your questions. My experience has been XYZ manager, whoever that person was, Joe manager, in the past, hasn't done it in a long time. And so you start talking to them and they think they know exactly what's going on or how it's working, but they haven't done it in a while. And I fall in that same category, as an IT guy. It's better if I need to know exactly how, something's not working on a network or something's not working. I go get my guy who's doing it day in and day out. So, hey, let's help me through this, because there's things I just don't do. I just don't, as a manager, get the people who are doing it day in and day out. They are the smart guys. They're the people you've hired to do this, and they're going to answer the best questions. It's always hard to fight that battle where they say, well, they're too busy to do that. And I've lost that battle several times. And guess what happens in the project? The project ends up being more difficult. We don't get we don't understand fully what the system needs. And it becomes problematic. And then everybody, no, not, I wouldn't say everybody's dissatisfied, but it just doesn't, you don't meet the needs. I'm really big on that. Get the people who are doing it day in, day out. And then the last thing is stakeholders. There's a lot of other people too. This is just the ones that the book highlights. The stakeholders are the people, it's the important people in the organization. And as we're going through this, I'm going to talk about, you get sign off, or you have to get approval to move on, or make sure you're going in the right direction. Stakeholders are the important people in the organization. They're the ones that say, yep, that's what we wanted, or nope, that's not what I wanted, and nope, I'm not willing to pay for that. Most importantly, that last piece, I am not willing to pay for this. And they're usually the stakeholders. They're the people who have some stake in the organization, and they're going to say, whether you can go on or not. They can help champion the cause and make sure that you have enough money and resources to do what you need to do, or they can say, forget this, I'm going to shut this down. And so you really need to make sure you understand their needs within the process as well. All right, let's move on. Let's start talking about some of these different steps now. Like I said, we're going to go through and talk about some of these different things. The first thing on that SDLC is this thing called investigation. And this is kind of an interesting one, because in most organizations I worked at, we never really considered this part of the SDLC. This is kind of the process when you say, okay, we have some business needs. And if I went back to that little chart that shows the whole, the thing across the middle, this is where, okay, we have some business need. We want to do this. The thing, usually you do these feasibility studies prior to starting the project or really doing it, because this is where you usually say, okay, is this something we should take on, or should we not do it, or should we not do it at all? It's not feasible for, the feasibility is the key word. Notice each one of these have that word in it. So the first thing we want to look at is technically feasible. Technical feasibility is, hey, we're looking at this capability, but is the technology there to enable us to do what it is we need to do? And I'll use this example. One of the things back several years ago, we were going to do a project, and it required us to use facial recognition. This is probably 10 years ago now. And facial recognition at the time, it was available, it was doable, but it wasn't real good. We didn't have, like today, facial recognition in everything. Our phones have it. It's widely used, very, very much. It's matured a lot more, and so it would be technically feasible today. But back then, when we're looking at this, yeah, we could try this, but it raised some certain amount of risk to the project. And that project, we ended up killing it at this point, because It just technically wasn't feasible. So that's one of the things you want to look at. What are all the technologies we're going to probably need in order to make this work? And we need to see, are they feasible? Are they mature enough? I guess it's probably a better word. Are they mature enough to be able, for us to be able to use it and implement it and have a successful project? The next one, economic feasibility. Economic feasibility gets to that money thing. Um, some of this technology, can we afford to do this? Maybe you're going to have to spend a lot of money for a lot of equipment. I'm going to have to buy all kinds of servers. I'm going to have to buy all kinds of monitoring equipment. That's probably a better one. Servers are, not because of virtualization and all the other different things. Servers are probably a little easier to accommodate. But let's say we have to put some kind of sensors all over a building in order or within the devices. And so that's just going to cost a lot of money, or maybe we're gonna have, it's just going to be very expensive. It's technically feasible, we can buy them, but we're going to need so many, the cost is going to go through the roof. Or we're going to have so many people, it's going to take a lot of bodies that people to do it. It's just not feasible. So economic feasibility is, can we afford to do this? Is it going to be within our, whatever financial resources that are going to be given to us or within the organization or that are available? All right. So then the last one probably less thought about, and a lot of people overlook this, behavioral feasibility. There are projects sometimes, when you go through and it's the human side of things, behavior kind of stuff. I've had projects where, we go through, and it's technically feasible, it's economically feasible, we can do it, but there's an acceptance issue. People just, I'm not going to do this. And you get a real heavy pushback from people. They don't want that change, or they don't want, they don't want to do it. In the sheriff's department, we had one application where it was mandated. It was a state mandated function. We had to do it. And so we ultimately had to do it, but it's kind of a good example. State came down, said you are going to do this and you're going to report this information on a regular basis. But once we implemented it into the systems and have everybody start using it, especially the guys on patrol, they were like, this is stupid. And they started playing games with it. They started putting false kind of responses in, because it was just another burden, another thing. Oh gosh, another thing we got to do. And so it has a behavioral or a human side of it. And so we had to do all kinds of, because it was mandated by the state, we had to go through and we had to figure out, okay, we had to implement stuff into it. We started making reports. Who's doing this? And we started having people review the information. And if it looked like they were gaming their answers or not taking it serious, we had to then tell the supervisors, reports to the supervisors, or supervisors say, hey, you need to do this and you need to take it serious. Looks like and so all that kind of stuff comes into play. And so one of the things you might want to look at, that was mandated, so we had to do it. We had no choice. But in some cases, you might say, this is the kind of thing that people are not going to like. They're not going to want to do it. And we're going to have to spend a lot more money management wise. Our managers have to let them use more of their time because of that behavioral aspect of it. And let's just not do it. It's just really not worth the effort to, at that point, to deal with it. And then, so those are the three main technical feasibility kind of things. And once again, so there's go, no go. A lot of times you do a feasibility study in this investigation part of it, and you say, okay, yeah, it's all feasible, or yeah, maybe one of those three aren't really feasible. Let's not do this. It's a no go. We're not going to do this. Let's kill it right here. And like I said, and most my experience has been, this is usually kind of done before we consider it a real project and we do feasibility to see, is this something even worth going down that path? And in most cases, and in a lot of time, my training was actually the real start of the SDLC is the next block. It's when you start doing the analysis. We believe it's feasible. And so now we're going to do this analysis phase. All right. And so let me talk about what the analysis usually is. All right, so now we're going to do it. Okay, well, now we've decided, the organization's decided they're going to put some kind of resources towards it, some financial resources and bodies, people. And a manager used to always say, we need more belly buttons. He called people, the number of people we had on a project, the number of belly buttons. It's kind of bizarre. It's kind of funny to me. Anyway, systems analysis. Now we have to figure, okay, and the key word here, and I have it in quotes, is what? What is it you want? And when I showed that chart at the beginning, that little cartoonish thing, that's not in the book, that was, the analyst's job is to go out and say, all right, well, what is it you need? What is it? And you got to ask a million questions. And once again, that's why a person, maybe somebody in this program who has training in business applications as well as technology, they have a better opportunity or better knowledge of both sides, and they can ask a lot of questions. Well, what does it need? Well, and they explain it, and you say, well, what does that look like, or what is that, how's that? And you just, most of the basis of most of your questions are what you just keep asking. And a good analyst can, drill down and get, really a firm understanding of what the business needs are, and ultimately what we call these things called requirements. And so that's the key word. What is it that we're trying to build here? And then the next bullet here, I would say, me personally, this is that there's a lot. If you go back and look at a lot of, documentation or papers on the SDLC, most of them will tell you that if you do this part right, the what part of it is the most critical and most difficult. Having people that are good at asking all the right questions and get to the point where they really understand the business needs and business problem, then you will do well. But it's not always intuitive. It's harder. You don't find these people a lot. So it's difficult and it's critical. And one of the reasons it's critical is hopefully it's intuitive, but if you don't really fully understand what the problem is, and then you go on and you start, which we'll get through some of these other things, designing, coding, testing, and you do all these other things, you really didn't know what you were building. That's when it gets very difficult. And one of the things, and I'll maybe reiterate this a time or two, but one of the things that can happen is you get downstream and you didn't really understand the problem. Now, because you didn't understand it, you had a bad design, you programmed it bad. And so now to tear that out and to come back and redo a lot of things can be very costly. So it's always, for me, I was always very strict on, all right, let's make sure we spend enough time. Let's work hard and do a good job at developing and understanding the what's, because it'll kill you downstream if you don't. And so anyway, very typically, you have a deliverable that comes out as systems requirements document, sometimes, business needs document. There's all kinds of different names for this document. I think if you look in, most of the traditional SDLC kind of stuff, it'll call it a requirements document. That's the way, back in my day when I was doing development, that's what we had a requirements document. And sometimes we got very thorough, and we had these big fat, 3-4 inch paper documents. Now a lot of it's electronic, but we had big documents that, full of these requirements, very, 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 very detailed kind of stuff. And in the strict SDLC, once again, one of the things that you do is, because if you're doing strict SDLC, at this point, you would take that document, the SDLC, and the requirements document, excuse me, and you would give it to the users and say, okay, read this thing, and make sure, tell me, is this what you want? Once again, the keyword what. Interestingly enough, though, what's difficult with it is a lot of times your users, sometimes we write these documents in ITEs, or IT type words, and the users look at them, they go, they don't understand it. It's very detailed, probably using kind of techie terms, and that's another area where the process can fall apart, because they'll look at it and say, and even though, like, if it's a large document, it's overwhelming. I don't want to read this thing; it's too much. And so a lot of those things, those are some of the reasons that the SDLC fails. But once again, if you do it well, it can work. All right, so now we got all our what's. We finish with all how we're gonna, what it is we need to build. And so we go into this thing called design. So we have a thorough understanding. And so now we start looking for designing. And designing, and I didn't put that in here in the chart, but design, a lot of times we kind of, the key word for that is, okay, I know what it is. Now, how am I going to go build it? So I look at the inputs, the outputs, the user interfaces. We start looking at how we're going to make this. Okay, how am I going to get inputs from them? How, what kind of things are we going to do? How do I want to present that to the user? And then I want to put the outputs, where does that go once I get some kind of result? So all those kinds of things. And you look at this shopping list of stuff there in the second bullet. What kind of hardware am I going to need to put this on? Do I need additional software? Do I need what databases do we need to develop? Do we need telecommunications? What kind? And so it's all these things, personnel, procedures. What are all what do we need to build the how part of it? And so that's where you start looking at, coming together and figuring out, okay, we know what it is now, but how do I build this thing? And then you ultimately put together this thing called a blueprint, and a lot of times there's many different ways of designing. There's data flow charts, there's process flow charts, and that's where you start seeing. And I think I talked a little bit about those in some of the earlier chapters, of those things, and the design type documents that you put together: data flow, process flow, and maybe an architectural design of how where things are going to reside, and all that stuff. So that's what the design phase is primarily for. And then now we're going to introduce this thing, and this next thing, this thing called scope creep, is something we deal with throughout. And if you're a project manager, and that's what, once again, I was a project manager as part of my career as well, and I do teach the PM class. Scope creep, that's when, okay, now, and a lot of times we call the requirements, I maybe should have introduced it back then. We also call that your scope. That's what is the scope of the work you're doing? What is it that you're going to build? So we have it and we get it all decided. And as we're going through, one of the things that, and especially at this phase, one of the things that starts happening is, okay, yeah, we had them sign off on it, but we're starting to design, and then all of a sudden, oh, well, and this happens on both sides of the fence, the users as well as the development team. Oh, we had the requirements on, and now we're kind of getting into the how a little bit of it. Oh, well, there's some really neat functionality we could add to it. And so your scope, you can start saying, oh, yeah, we had the requirements bounded and we know what it was, but let's expand that. Let's, the scope being your requirements. Let's expand it because this is kind of cool stuff. And that becomes very problematic if you're a project manager, because usually you have a budget given to you at this point and a schedule. And if your scope starts growing, well, that becomes very risky. And it's kind of maybe an offshoot example. I do a lot of work around the house, and even with my automation, I'll start, building something and I'll start automating something. And then I'm like, oh, wow, I just discovered something else. And if I just add another sensor somewhere, if I do this, right, and then my scope grows, well, then, for me, it's just me. I can decide, do I, and, I guess, do I have the money to afford another sensor or two, or can I do all these things? Yeah, and my scope grows. But that's as a project manager, one of the things you have to watch out for, because when your scope grows, usually your schedule gets blown up, and then as well as your costs go up. So you really need to manage scope through the remainder of the project, all the things we're going to talk about. Very typical thing to do. I don't think I talked about users. Sometimes you'll see, they'll come in after the fact, and especially when we'll talk a little bit about prototyping, you'll show them a prototype and they'll say, oh, yeah, that's really cool. But, oh, I really wish, can we add this to the screen? Can we add that? And they'll blow up your scope too. And so that's one of the really tough things for a project manager, the PM, is to maintain that scope at some point. And maybe I'll talk about that in a second. All right, so then we get done with that. We've got our what's, we figured out a lot of the hows, and now we're going to go into the programming and testing. Programming is that function of, now we're going to throw and this is a software kind of based. We got our what's, we know how we're going to build it, we've figured out our design, and now we're going to start coding it. We're going to do the programming of it, and so we turn that design into a computer generated code. And once again, I mentioned the hardware aspect of it. Very similar. Hardware, you do the same. I've managed hardware and software developments, and some of the hardware stuff is, okay, we're going to build. We got to build a let's say in electrical engineering kind of thing. We have a printed circuit board that we need to build. They go through same kind of stuff. You need to get your requirements. You need to design it to kind of get a feel for how you're going to lay it out on the board. And then when they get to this point, now they start putting it. they start putting it onto a integrated circuit or circuit board to, put all the resistors, all the chips and everything on there to actually to build it. Yeah, so that's what they do. In mechanical kind of stuff, it's in I've known a handful of mechanical engineers. They, what they typically do is call it, we start bending metal, we start, making stuff and building things to actually, to start making whatever the product is. But for software, it's the programming part of it. And we use modern programming, different languages. There's a boatload of them out of there, and you can. I'm not going to get into favorites first. I am a very big proponent of use tools that you're used to, that your team is well knowledgeable about. So if you start using a language that you're not familiar with, chances are you're not going to use the language as efficient or as best you can. And actually, one of the things I remember, back in my early days when I used to actually develop and I wrote code, I'd use a development language, and I would write the code, and then I wrote it, and then I didn't really get good with that language, and I learned all the constructs or how to use it very well until I got towards the end and said, oh, okay, now, oh, I know. And you always look back at, something, not always, sometimes you look back and go, oh, I should have done this that way, but I really don't have time to do this. Schedule's moving on. I just got to leave it the way it is. And so, but after you use that language or that technique several times, you get better at it. And just like anything else, the more times you do something, when I'm building something, I'm much better at wiring a room now than I probably when the first couple of times I did, all that kind of stuff. So you get better as time goes. And so use a language you're familiar with, as well as some languages work better in different applications. And I'm not going to get into what types to use. If you have a question about that, maybe send it to me. I may have to tap some of my programming buddies and get their input too. But nonetheless, those are the important things to think about, and that's what you're doing. So then after you do the programming, then we do this thing called testing. And once again, my training back in the day, we always separated out that we're programming of the actual coding part of it was separated. It was considered a different block on that diagram than testing was. I like that concept, although there is some level of overlap between the two. Testing is very, very important. And usually I would say, that first one there, unit testing is, okay, the programmers, we give them, they go off and we give them the design and they start writing code. Unit testing is usually done, okay, I have my segment. I've been allocated this part of the program design, and my job is to develop and write the code for it. So I started using, and one of the things unit testing is, okay, I'm the guy responsible for making sure my unit or the things I've developed work the way they're supposed to and fit into the bigger picture of the application. And another important kind of thing, testing is always done according to, usually test against the what. Go back to the analysis. This is what we're supposed to build. So the units or the ones I'm building need to be tested against the requirements for that. And so all of my testing and all the testing should be done against the requirements to make sure you met all the requirements and it does what it's supposed to. And if you've done everything along the way correctly, it should, all line up. So next thing, we have integration. Let's say we have a team of people. There's 10 people. I've done all my units and I've tested them out and they all work, at least I feel like they do. Then you put them together. I say, all the people, all 10 of the team, we integrate them together and we see, okay, does this work? Are they, if they're, I'm not going to get too much into it. If I call this out, this routine, do the calls work correctly? Does the information get passed back and forth? Is the information I expected coming back? And so you're integrating all the different pieces together. So after you get that done, you test that to, once again, you make sure it still meets the requirements. And then you integrate, it's all integrated. Then you do systems level testing. Okay, now we have the program, we have the application. And when I was doing defense work, we didn't always have the luxury of the equipment. Some of the hardware was being built by, maybe another vendor, or maybe we were doing it internally. A lot of times during my years, we had the hardware was built by other companies. We did some of the software, and so it was very different. So that at this point, though, you put it on the actual system if you didn't have it running on the hardware that it was intended for, and you start running all your tests once again to make sure it's working. And this is usually at a higher level. It's an abstracted, really looking at it, start looking at those user interfaces and make sure it works. And then you get to the next step. This you can call user testing. User testing is okay. Now I feel pretty good about this. The system works like we thought, and well, look, cut it loose. Let the user start playing with it and see, a sample probably of those people who helped you at the business, people that helped you, the users that helped you at the beginning. Turn them loose on this and let them start seeing, this works exactly over there. Oh, no, you kind of missed it on this, buddy. So those are things you kind of do. You have user testing as well. And then the last thing is usually, and this one's usually kind of what we call a dog and pony show. It's kind of everybody's tested it, and it's usually just like a show to tell the people at the highest level, the stakeholders say, okay, let me show you this. You paid me all this money. You gave me a schedule and scope, and I'm just here to prove to you that I delivered what you entrusted me to build. Um, so that's the multiple steps. Once again, very, very important. And I think I mentioned last time, one of the things, very frustrating for me. This was beat into my head very much that you make sure you test the heck out of things. I don't know. I just think it's embarrassing if I didn't do my unit integration system testing and I turn it over to the users and it's a few little mistakes, it's going to happen. But if it's just crashing left and right and things just don't, it's just a horrible product. You haven't really done enough testing. I just think it's embarrassing, and you shouldn't do that. It gets done. Sometimes you get schedule crunches. You underestimated how long it was going to take, or not enough people working on it, or whatever the dynamics are of it, and they throw it over the fence anyway and let the tear, and it's just a mess. As a project manager, that is something I try to avoid at all costs because I just don't think it looks good. It gives, I'm an IT guy, and it makes us look bad in my opinion, but it happens. And there's some organizations, there's some big companies that what they do is they develop a program to a point of this is good enough. Let's let the users, go ahead and massage it and find all the issues for us, and then we'll fix it. And they just don't care. They'll just do it that way. And that may be your business model. I just don't personally feel comfortable that way. All right, so now we've got it, and we have got it all programmed and tested, and we put it into this thing called implementation. Implementation, put it into production, go live. There's all kinds of different terminologies that we use. It depends on whatever you're used to or whatever your organization is comfortable with. And the next question is, how do we do that? Now we're going to implement this. How do we go about doing that? Different approaches, different ways to do it. The first one is what we call direct conversion. And direct conversion, that's usually the way I like to look at direct conversion. It's kind of out with the old, in with the new. You just cut off the old one and start with the new one. I like to talk, the example I like to talk about this one is like an accounting program. Accounting turned out to be a very good development application, or it has a lot of good examples in it anyway. Let's say we implement a new accounting program, and we say, okay, we're going to do that with a direct conversion. We're going to just get rid of that old one, and we're going to, on Friday we finish with the old accounting program, and on Monday everybody starts using the new one. And so that's what it would be, out with the old, in with the new. As it turns out, some of the issues or things you got to consider in that approach, and is that, especially with an accounting program, why I like to use it, is that one of the things that happens is accounting is a very, very important function within the organization. Your accounting gets all screwed up, you could have long term, it could sink the boat, kind of thing. So a lot of times what you do with an accounting program is, and the concept comes in is like, well, let's run these in parallel, which is the last. Maybe I'll talk about that one at the same time. So let's have the old one at the same time, and we'll run the new one at this and in parallel. So you run them, and one of the things that's nice about a parallel conversion, running them the old with the new, is that you can see, oh, okay, yeah, the numbers coming out right. Then, so the old one, you're getting the same results, but the new one's kind of nicer interface, easier to use, but all the hopefully the reasons why you did it. And so you can have some period of time and you get a confidence level that yes, indeed, this actually works and we're happy with it. The downside to that is in a parallel conversion is that sometimes you got enough you got to double enter everything. You got to put everything into your old system, you got to put everything into the new system, and probably don't have the staff to do that. And so that's always the big question is in a parallel conversion is do you have the people to do it, or is it possible to actually do both of them at the same time? And sometimes yes, depending on what the application is. Accounting is funny. I've had experiences in the past where we did accounting systems, and they're like, there's just too much information. There's just way too much. We can't do that. So it tends to be a direct conversion. And for me, it's always like you kind of throw on the dice and like, and maybe downstream you figure out, oh my gosh, it's really not totally correct. But anyway, that's those are kind of some of the options you do. You directly convert it out with the old in with the new, or run both of them in parallel to make sure the new one does exactly, or it runs correctly as you're getting the same results as you would have gotten with the system you had before. All right, so the next one, a pilot conversion. A pilot conversion is usually, in these next two are kind of similar, but there are differences. A pilot conversion is usually where you run the entire application. You have the whole thing running, but you're only trying it in a portion of the organization to kind of see how it works. I think I talked a little bit about the body-worn cameras. We did a pilot when I was still there, 3, 4 years ago. We ran a pilot of a body-worn camera, put these body worn, had a couple different um, part of the organization's little patrol. I couldn't think of the word patrol to use. We had different patrol stations, Highland, I think Apple Valley or Victorville. It was one of those two. We did it, and then there was one over in the West End, ran it too. Put them on it, see how it works. Let them full functionality, let them run, see how it goes, see how much data we're collecting, see what's working and what's not working, things we need to change. And that's the purpose of it. You test, you kind of see in a smaller portion, subset of the organization, how well it works, and then you can do tweaks to the application to make it run, and then before you put it out to everybody. Very, very useful technique, very, very common. The next one, phased, is it's very similar, but a phased conversion is usually in that you don't use the full application. In a phased conversion, and let's say an ERP might be somehow you do an application where you do this, where you have accounting, you have HR, you have all these different functions within it, and you say, okay, we're not going to put all those out. We're going to put it out to the whole organization, but we're only going to put the accounting function out, or we're only put the HR function out to everybody. And so you phase the pieces of it versus in a pilot, you put the whole thing out only in parts of the organization. Two different ways to do it. And depending on what what your needs are, or how you're going to do this, or what your business needs are, how you want to implement. So those are kind of the different approaches. And there's hybrids of these, as you can well imagine. I think I've probably done to some degree each one of these at times, and they all have their pluses and minuses, and you just kind of have to adapt to whatever makes best sense for you. All right, so now we get done. We implemented. We figured out how to get it out there, and now we're all done. It's working. Hopefully, working, and in a perfect world, it's the thing just hums right along. You have no issues. But let's sprinkle a little reality into the equation. And sometimes you miss certain functionality, or you thought you tested the heck out of it, and there's a bug in there, a bug being it doesn't work exactly the way it was supposed to, or now you see problem. So you got to come in and you got to you got to go back and fix some code or make changes. It could be an update, and I think I mentioned a little bit last time when I was talking about this, especially in the world of where there's some kind of when I was in the assessor's office, it's a legal process. It's defined by the Revenue and Taxation Code for California, and every so often they change the R&T, as we call it, the Revenue and Taxation Code, and they would come in and say, okay, this is the way you calculate property values. They've changed something. So we'd have to go in and update the program based on some regulatory mean. It could be, your business needs have changed. The way you interact with your customers has changed. It could be whatever the difference, whatever, your needs are. So you need to make changes. Could be you need to update it because you've discovered an exploitation of your and a cybersecurity problem. So it could be an update for that reason too. And then the last thing is you might want to add some new stuff to it. I'm going to kind of jump back and talk about that scope creep thing that kind of can happen in all these different phases. Somebody, you get in the programming or stage, and all of a sudden everybody's like, oh, this is some new stuff. What I have done in the past, and a lot of times is okay, that's a great idea. I tell the team, let's keep that. And what I've always called it was my list of enhancements. Okay, keep that idea. That's a great idea. It's not in the original requirements. It's not in our business needs. So write that down, and we're going to keep track of that, and we're going to call it an enhancement, our enhancement list. And at this point, we get into it, the operations and maintenance, and we say, okay, we have this is the list of enhancements we came up as we were doing going through those other processes. You go to your whoever the sponsors are, or your stakeholder, and say, listen, we gave you what you wanted, but these things cropped up either from you or from us with things we thought of, and we think this would be worthwhile to add these enhancements. And that's when, if you're, you got to sell it. You're going back to the trough and saying, hey, we want a little more schedule to start building some additional stuff, and we want some more money to do it. As a project manager, that's, sometimes they're looking at you like, hey, how come you didn't do this originally? And it's like these cropped up. These are enhancements not originally envisioned, and everybody signed off before. It's all that. There's some politics in there, or some, you got a salesmanship perhaps as well. But those things crop up in there. And a lot of times your operations and maintenance, after you implement, this is the life of the program or the application until somebody deems, we don't need this anymore, or we need a new one. All right, so now we've gone through pretty much all of the SDLC. I'm going to talk a little bit about some of these other things, alternate methods or tools that are used to help you through that. And some of those were shown on that chart earlier on. This guy up here, I'm going to bounce up there real quick, and this guy. So now we're going to talk about some of these other add-on kind of things, or ways to make this process work a little better. Goes right here. Nope, we're right here. All right, so the first thing here is this thing called a JAD, or Joint Applications Design, which is an interesting term. And I believe, if I'm not mistaken, I have to go look this up. I keep saying I'm gonna look it up. I never have. But I think it was originally developed by IBM as a methodology. And one of the things, the Joint Application Design, which it's really kind of a tool to help kind of weed out or get out, pull out from your users their requirements. And it's the joint application is the big part of it, is where it's really big on these are the, and it's a tool to help you ask better questions. What? And if you use it correctly and use it right, it will really help create better requirements that will get you a good, strong leg up on building a good design. And hopefully this diagram, they actually, they're showing it right here. So it's actually done a lot in here, and it gives you something that is in your deliverable design documents. I might bounce back and forth on that because it's really helpful. So that's what the JAD is. It's tools, electronic, automated tools to help you get better requirements. The next one is a rapid, oops, chart over here. Not kind of a couple charts behind, not keeping track of what I'm doing over here. The next one is rapid application development. Like I said, that whole formal kind of, and the SDLC is very structured. You do the requirements in the analysis, and then you do design, and you don't jump from one to the other until you've got all of them. Well, that rigidity kind of forces it to makes it more expensive, makes it much more difficult. And so a lot of places said that we need to circumvent that and speed it up. So part of rapid application development, and one of the things they do in that is to say, okay, we're going to start, we know this part of it, and we're going to start the requirements on that. And then we'll start doing some design, And this over here, there's requirements that we'll figure those out after we've done the requirements design, maybe some programming and testing in here, because these really probably there's very low probability they're going to affect that. So there's no risk of doing, we don't have to do all the requirements for the whole application. Let's start doing some requirements. Let's do some design. Let's do some programming. Let's work our way down and then start some requirement. And so you're actually you're kind of iterating on it. And that's probably one of the advantages of that is you can actually use your programming team a little more efficiently, because especially when you get your analysts are the people that are good at doing requirements, and they may turn that over and they may do some of the design. They may are, depending on how the skill sets of your team. But then when the programmers, usually a different set of people. So now you can, as you're doing the different parts, you can use your team a little more effectively. So that's what, you don't finish all the requirements, you don't finish all the design, you can iterate on it a little more, a little more wisely. Development ops, that's a terminology, and it's just this just makes good sense to me. Development operations are the way you do things. It's kind of a process way, and it defines, you co-locate your teams together. I'm very, obviously, I think a lot of communication. I think the more communication you have between your development team and your development team, the programmers and and then your user base, the more communication and the more they're working together with each other, the higher probability you are going to, have a better quality product. The downside, once again, you got that scope creep thing. They're sitting together and they're like, oh yeah, that's great. Why don't you do it? And they get to be good buddies, and you have a user and a developer kind of sitting and they're, yeah, well, I'm not going to tell the project manager. I'm just going to build that for you. And next thing you know, that person gets behind on their schedule for their part of the application. It's a project management kind of concern, but ultimately, you do co-location, and having your development team with their users is always very. I think you have a higher probability of getting a really solid product. The next one, agile development. Agile is a whole process. A lot of classes are taught that, I could spend a whole class session at least in just explaining agile. Agile in general is a very well defined, and it is very communicative in nature. It defines, okay, you're gonna have a meeting. You're gonna have these things called scrums. You're gonna have swim lanes. There's all kinds of these terms, and it's very much set up to create that communication methodology or path to get everybody working together and working harmoniously. Very popular now. It's very successful. Takes a lot of the good stuff from the SDLC. It's basically using the RAD thing, the rapid application development, uses methodologies from that. So it's a very, very solid approach. More and more popular. You see it used more and more. I'd almost like to see this text transition to the agile approach and make that the primary focus of this chapter, and then talk about the SDLC, some of this, and maybe talk the history of how some of these other, anyway, like once again, when I write my book, which never happened, maybe I would do it that way. Anyway, the next one, end user development. End user development. Now with a lot of tools, back in the day, when I was doing development, it was all very techy, and you had to know some very specific development languages and very, very techy kind of stuff. Over time, more and more the tools are, I guess, they're abstracted to some degree, and so users don't have to be nearly as, you don't have to know that really hard the terminologies and the language. You don't have to be as knowledgeable. So there's a lot more end user development tools that are available, and so, and actually, to some degree, if you've ever used Microsoft Access, I would call Microsoft Access in kind of, it's a database application, but it's been made to make it easier for end users, the not necessarily the business aspect people, to be able to develop their own application. Absolutely good tools, and I am very firm. I am absolutely on board with letting users develop their own tools. But once again, I would say, and let them build whatever, use Access, use whatever tools they want. But you got to be careful as a manager to watch out for certain things. And I'll talk about a little an example of one of the things that's happened to me. We had end users tools, and as it turns out, we had a person in the assessor's office who had a computer science degree. So he's an appraiser. He was an appraiser too, a second level appraiser, and he started developing his own programs to help him do his appraisals much more quickly. Great, I'm on board. Yeah, I'm all good. I'm on board for people doing it better, faster, smarter kind of stuff. But all of a sudden, he was in one of the remote offices, and some of the people working with him, hey, that's really cool. Can I use that? He then expanded it for the whole office. Everybody in the office can use that tool. Here we are back, we're and we didn't call it headquarters, but basically the headquarters for the assessor. And we had no idea this is going on, didn't tell us at all. And so, as luck would have it, this guy gets a job in a different assessor's office in a different part of California, and he leaves, but that program's still running. Well, as I mentioned, the R&T, the Revenue and Taxation Code, comes along and makes a change, and these users also come to us and say, "Hey, we need somebody to edit or change this program because to incorporate the new laws." And we're like, "Well, what program?" And so now they got this program that doesn't work for them. It's an end user, great program, but so we had it wasn't a huge deal, but we had to now get somebody on that right away, and we had to learn how we had to get somebody to go in there and fix and make changes to that application. Can be dangerous, and that one we were able to accommodate. It was a little of a panic. We had to do it quickly. So you got to be careful with end user stuff. You just got to make it well known. Hey, let us know. Let us be involved with that. Let's communicate and work together on it. And then the last thing on here is some tools for development. And that's actually the next chart. So I am going to jump right over that and go to the last chart. Always, like I said, my favorite chart in the in the deck. Some of the different thing. One of the first thing, design thinking, user-centered approach. I've talked about that a lot. You want to be thinking about a design, or you're making sure your requirements and your designs, your user interfaces, how they interact with it, works well for the users. It's very getting them involved with it, making sure that it's going to meet their needs ultimately. The next one, prototyping, and I'm going to jump up here real quick, kind of show you oops, not that one. How about this one? A lot of times it makes sense. You get into the analysis and you start saying, okay, this is what they're telling me what they want, and I think I understand it, but let's make sure I really do. So this prototyping idea is I build what we call a mock-up. It looks like this, but it doesn't really work. You take it to the user and say, hey, look, is this what you were thinking? And they're like, oh yeah, that works. It's not full functional, it doesn't work, but it's kind of a mock-up. It's a prototype of it, and they can see it and say, yeah, that's what you're on the right track, or man, buddy, you're going down a bad path, and you can fix it. So it helps prevent problems. The downside to prototyping, once again, that scope creep thing happens. I show you, oh yeah, that's you're nailing it, you got it. But if you also added this, and so you got to manage that if you're a PM or if you have a project going. The next one, integrated case tools, computer assisted software engineering tools. That whole process, let me bounce back over here. This process of doing all these things, no matter what methodology, and I will say that one of the things in the strict SDLC, you do all these things very rigidly, but you do most of these things in the other techniques as well. And the more you do them, the better you do them well, that makes sense. And whenever you got a document, a lot of times we want to document let's capture all those requirements. Let's capture and build a solid design. But making sure when you're in your design with all our how, do we capture all the what's in there? So it's making sure and tracing from here to here, and then do we program all the how in there? Do we implement everything? Doing all those steps can be very tedious. So there are case tools that do those kinds of things for you. Tracks and said, okay, yeah, this is, this what got put in this part of the design here, and then it's implemented here. And so it actually traces it throughout. So you've done everything. And they're just case tools to help you do that. The next one, component base. Now component based kind of stuff there, definitely early on when I was doing this stuff, we started talking about, man, it seems like certain functionality, maybe figuring out something like translating Fahrenheit to Celsius or something like that just popped into my head. Um, it's a very standard. Do I need to write code to do that every time? No, I'll just go get a component of that already does that, or a function that already does that. I'll implement that. I'll just put it into it, and it'll do all the things I need for me. And that's where we used to call them library functions, and you see more and more of that. Some of the open source kind of stuff, that's where you start. Yeah, somebody else has probably solved this problem. Let me go find some open source code, and build that in and make that happen as well. So that's another thing that's out there. Component-based development. Don't recreate the wheel each and every time. Use something that somebody already built. And the last one, another biggie, just like I'm not going to try to go through object-oriented development. That is kind of what we do now for the most part. In old school, when we did things most of the time, we looked at things functionally based. How does this function? How do they work? And the more contemporary way to think of it is look at things as objects. And I'm not going to try it. I've been trained, and I have I've never gone through start to finish in object oriented. I started getting into management and PM kind of stuff where I didn't really have to manage object oriented kind of development. But it's more, and most of the contemporary programming languages are object oriented based. And so that is the methodology. And once again, it's a whole course in how you do object-oriented development now. So I'm just going to say the only differentiation, or the only thing you really need from the perspective of this class, it's not functionally based, but it's how you look at things differently. You look at them and from the perspective of objects. All right, and that is the last slide in this chapter, and looks like it did take me about an hour. I thought it'd be a little less than that. Evidently, I got a little chatty or verbose. I don't know. Anyway, so that's the end of that. Any questions? I'm going to go ahead and stop the share unless somebody has a question about a slide as well. Any questions on any of this? If not, have a great weekend. Don't forget to do the quiz, and groups 5 and 6. If anybody out there is watching this is 5 and 6, make sure you get your assignment turned in by your group project by Wednesday at midnight. All right. Well, thank you as well, Josh. You guys have a good one. I am going to end the recording.